Hello students, today we're going to look at solving equations with fractions. So we're going to look at the procedure for doing that. There's 3 easy steps. The first one, we're going to eliminate fractions using the least common multiple or the least common denominator. There's a couple ways you can think about it.
The second step is combine like terms on each side of the equation.
And then the third step, we're going to just solve for the variable. You already know how to do steps 2 and 3. Let's get started. The first thing that we're going to have to do here to eliminate fractions is we're going to look at the denominators and try to eliminate the fraction altogether. So to do that, we're going to use the least common denominator. We're looking for the least common multiple within all 3 of our fractions. I'm looking at number 1 here. We have the fraction 1/2, 1/5, and 1/10. If we're looking for the least common multiple, really you're just looking for what number do they all go into. And these are just basic examples to start, but if we just think about it, we've got a 2, a 5, and a 10. And if we just look at the prime factorization for each, we have a 2, 5 is prime factorization is going to be 5, but for 10 it's going to have a 2 and a 5. So if we wanted to make all of these 3 statements the same, we have to fill in the factors that are missing. So for 10, we had 2 and a 5. So each of the other numbers here, each of the other terms is going to need a 5 in it. And this one's missing the 2. So you see there, and we have the same 3 expressions. They all would equal 10. Our least common multiple that we would be using if we were trying to eliminate fractions is going to be 10. Looking at the second one, our 3 denominators that we're working with are 3, 6, and 8. So we're going to take the prime factorization of 3, which is just 3. 6 breaks down into 2 times 3. And the prime factorization for 8 is 2 times 2 times 2, or 2 to the 3rd power. Now we just need to make each of them the same. So this bottom one here has 3 2's as factors in it, so each of the other ones are going to need 3 2's. And then our number 6 here is 2 times 3, so it's missing just 2 2's. And then our 8 is missing the 3. So when we put it together, we have 3 factors of 2 and a factor of 3. If you multiply that all together, you're going to end up with 24. So our least common multiple for those is going to end up being 24. Okay, it's the same thing as saying what number do they all go into, but this is the mathematics behind it in case you need to do it. All right, moving on to our first example.
All right, first example. So we talked about finding the least common multiple of the denominators by the prime factorization. You could also just list out the multiples of the denominators until you reach a common one. So for here we have, again, 8, 5, and 2. So we could list multiples of 8, so we'd get 16, 24, we could keep going like that. Same thing with the, that would be a 10, 15, and 2, 4, 6, we could keep going. Or we can do with the prime factorization. So 8 would become 4 times, no, not 4 times 2. 2 times 2 times 2. 5 is just 5, and 2 is just 2. So like we said before, this has 3 2's, so everything else needs to have 3 2's total. So that one is just missing 2 of them. And now we need a 5 with everything as well. So if we multiply all of these parts of the expression together, we'd get 40. So our least common multiple will be 40. So we can multiply each of the sides by 40. You could think about it as 40 over 1 also. Oh my. Next thing, we could multiply all the numerators by 40 and then divide by the denominators. So if we did 40 times 7, we'd get 280x, and then we'd have to divide that by 8. But that's making the numbers pretty big. So what we could think about is doing 40 divided by 8 first, and then multiply that by the numerator. So 40 divided by 8 would be 5. 5 times 7 will be 35, and then we'll have the x with it there still. So for the next one, we could do 40 divided by 5. That would give us 8, and then we'll multiply that by 3, and get negative 24x. On the other side of the equation, same thing, 40 divided by 2 will be 20. 20 times 11 is 220. So here's the equation. Now we have no fractions left. We can just combine our like terms. Or on the left side is only where like terms are. So 35x minus 24x is 11x. And this side is the same. To undo the multiplication, we will divide both sides by 11. And we'll get 22. No, 20. Just kidding. We could check our answer as well. If I said 22 and that was the answer, we would plug it back in for the x positions, and we'd see that was not true, but 20 actually does work. For time's sake, probably skip plugging that in for now, but you could probably do that to check. For number 2, we have very similar things, but now we have some parentheses going on. But we're going to find the least common multiple of these denominators in kind of the same ways that we did before. So let's say 8 would be 2 times 2 times 2. 2 is just 2. 12 would be 2 times 2, that's 4. And then a 3 would make 12. So we have, let's see, 3 2's here. So everything else will need 3 2's all together. This one will just need one more. And now everything else needs a 3. So now they're all together there. So all those things multiplied together, 2 times 2 is 4, that times 2 is 8, 8 times 3 is 24, so our least common multiple is 24. So I'll multiply everything on each side by 24. And I'll do the same thing and just kind of do 24 divided by 8 first, so the numbers stay smaller versus getting bigger first. So 24 divided by 8 is 3, 3 times 3 is, we'll have 9x, the x is staying in there. 24 divided by 2 is 12. 12 times 1 is just 12. The other side, we're only going to be using the 24 with the fraction. The stuff in the parentheses, we're not going to do anything with right now because we'll distribute later. Or you could also distribute first, but we're not showing that strategy, I guess, right now. But up to you which way you like. So 24 divided by 12 is 2. 2 times 5 is 10. And then we'll keep this x plus 2 how it is. Then we'll distribute the 10. 10x plus 20. This side just stays the same. And we will combine our like terms. There's nothing to combine on each side. We got to start moving stuff over. So take away 9x. And then we will take away 20. We'll get negative 8 is our missing value there. So again, you can plug that in to check.
Just so you know, as you're going through and doing these, please feel free to pause the video if you want to work ahead and see if you know what you're doing. The great thing about the videos is you can fast forward through, you can rewind if there's something you didn't understand, or mark a spot there where you have a question, okay, and then we'll talk about it in class. The third example here, we're going to look at when you have a variable in the denominator here and the actual equation is set up as a proportion. So the problem we've got in this one is 5 over the quantity of x plus 1 is going to equal 2/3. We can do this the same way you were just doing it there by finding the least common multiple of the denominators. We have a 3 in one of them and we have an x plus 1 as a factor in the other. Well, when you look at the prime factorizations, both of those are prime. So you would have 3 times x plus 1 and then 3 times x plus 1. Now you could take it and multiply both sides by 3 times the quantity of x plus 1. But look what happens here. When you do that here, your x plus 1's will end up canceling out and you're left with 3 times 5. And on the right side, your 3's would cancel there and you'd be left with 2 times the quantity of x plus 1. If you go back and think about it here, and you've learned this strategy in the past, if I do 3 times 5, and I do 2 times the quantity of x plus 1, all I'm really doing here is cross-multiplying.
Yeah, you're just cross-multiplying. Okay.
So some good stuff there. All right, so what we're going to do here, just go ahead and finish out the problem. This is back to basic algebra 1 now. We've got 15 is going to equal 2x plus 2. And so we're going to subtract 2 from each side and divide by 2. And we get that x is equal to 13/2.
Could I say it's 6.5?
Sure, that's extra work, but yeah, we could say 6.5. And I know most of the students will want to do that there. But it's okay to leave numbers as improper fractions in Algebra 2. All right, let's move on here to the next example. Now, our equation is not set up as a proportion. Okay, so we have to look at our least common multiple, and you could probably do this one in your head, right? And at any point in time, if you can do them in your head, totally do that there. I'm just doing it for the people who may have questions. So I have an x, I have a 2, and I have a 3. All 3 of those are already prime, so their prime factorizations are just themselves. But we would then need to just fill in the other factors. So they would all need a 2, they would all need a 3, and they would all need an x. So when you multiply those all together, our least common multiple is 6x. We're going to take that now, we're going to multiply both sides of the equation by 6x. 6x times 4 would be 24x. Right now that's still over x. 6x times 1 is 6x, and that's over 2. And then 6x times 1 on the other side is 6x, and that's over 3. Now, I'm only doing this now because I have variables in the denominator here, and I want to make sure that we're focusing on canceling out factors that appear both in the numerator and the denominator. So you'll see here our x's will cancel out here, leaving us with just that 24. And here we've got the 6 and the 2. Well, 2 goes into 2 once and goes into 6 3 times. So we're going to end up there with 3x. And then on the other side here, you've got your 6 and your 3 here. 3 goes into 3 once, it goes into 6 2 times. Now you don't have to show all those steps here. Like I said, we're just trying to make sure that everyone is following along and understanding what's happening there. Subtract our 3x from each side, and we're going to say that 24 is equal to the opposite of x, which means that x is going to have to be negative 24. Now just take my word for it here. I know it's right, but you could always take it and plug it back in when you're doing it at home there. All right, let's hit up the last example here.
All right, example number 5. We have variables in the denominator again, but we do have something that's not even a fraction at all. We have this regular 6, but we could make that into 6 over 1 if we want to just kind of keep it consistent so everything is a fraction. So if we go through our least common multiples here, everything has an x except the denominator of a 1. So we'll definitely need that. And then 3 and 9, if I list multiples of 3 and multiples of 9, the first one I'd get to is x. So our least common multiple will be 9x. So we'll multiply everything on each side by 9x. Also multiply the numerators first and then show with the denominator there. So 9x times 5 would be 45x over x. Keep that there for now. If you want to just simplify right away, that's fine too. And 9x times 1 is 9x over 3x. On the other side, 9x times 6 is 54x over 1. And then we'll have 9x over 9x. So now we're going to simplify and cancel those common factors. So we'll have 45 for the first term. The next one, the x's can reduce there, and then 9 divided by 3 would just be a 3. 54x, that just stays where it is. Dividing by 1 doesn't do anything. And the last one, both of those things are identical, so we will just have minus 1 at the end. We can combine these like terms here. Those will just be 48. And then we'll add 1 to both sides. We'll get 49. Our last step, we'll divide by 54. And so we get x equals 49 over 54. So this
Wait,
one is...
can we have a fraction as an answer?
You know, it happens, and as long as you could plug it back in and check, this one is correct, and it does happen sometimes. So if you get a fraction, I would just double check all of your work, but it's a possibility for sure.
If you have questions, make sure you mark them down, bring them to class, and we will gladly answer anything that you've got. Thanks for listening.